Hey guys, today's video is on simplifying square roots. Normally, we can do square roots pretty easily if they're like the square root of 16, which is 4. But like, how do we simplify weird square roots that are not perfect, like the square root of 12? The way we do this is we're going to break up that number into the largest perfect square and another factor. So for example, the perfect squares are 1, 4, 9, 16, 25, 36, 49, etc. Then we're going to take the square root of that perfect square, put it on the outside, and keep the other number, the other factor that is, on the inside. Let's do some examples. Number 1, the square root of 24 can be broken down into two factors, the square root of blank and the square root of blank. We're looking for the biggest perfect square that goes into 24. Biggest perfect square is 4. And then the other factor, 4 times 6, made the 24. We can do the square root of 24, or the square root of 4 that is, and make 2. The other factor we cannot, and we leave it as the square root of 6. That is it. Number 2, the square root of 48 can be broken down into two square roots. The biggest perfect square that goes into 48 is 16. 16 times what gives you 48? 16 times 3. So we can do the square root of 16, which is 4, but we cannot do the square root of 3, so we leave it on the inside. The number on the outside is the perfect square. The number on the inside is the one that cannot be simplified. Let's do 63. Think about the biggest perfect square that goes into 63. And when you're doing this, guys, I would recommend writing out all the perfect squares at the top of your paper. So that could be broken down into 9 times 7. The square root of 9 is 3, and you leave the other number in the radical sign. The square root is called a radical. The square root of 90, the biggest perfect square, surprisingly, that goes into 90 is also 9. There is no other bigger perfect square. So it ends up being 9 times 10 gave you 90. So we can do the square root of 9, which is 3. We cannot do the square root of 10, so we leave it just like that. Let's go back up and look at some more examples, maybe some bigger numbers, maybe a little more challenging, like the square root of 162. After multiple tries, 81 is the biggest perfect square that goes in at 162. That's 81 times 2 gave you that. So the square root of 81 is 9, and then you leave the other one as square root of 2. Try number 6 on your own, see what you get, and check with me. You should have gotten the square root of 4 times the square root of 7, which is 2 square root 7. Let's go down and look at 7 and 8. And for number 7, the biggest perfect square is kind of large. It's actually 225 times 2 gives you the 450. And the square root of 225 is 15. Because 15 times 15 gave you the 225. So sometimes your perfect squares could be pretty large. Make sure you always check those big perfect squares. And then 343, the biggest perfect square that goes into that one, I'll let you think about that. Take a guess. It is 49. It's actually 49 times 7. So the square root of 49 ends up being 7, and you leave the other perfect square just like that. Let me know what questions you have on simplifying these square roots. Not too bad, I don't think, but this will help us in our next topic about solving quadratics through the square root method. Have a great night.